Dione, named after an ancient goddess, is a distant icy moon of Saturn. One enigma of her grace is a scar, the Wispy Terrain, which is named after its appearance. Higher resolution images revealed the chasmata of Wispy Terrain, a complex pattern of faults and troughs, and fueled further studies about the region's geological evolution, but its origin remains one of the Moon's biggest mysteries. Impact craters with a variety of morphologies may help answer some questions about Wispy Terrain. Polygonal craters have edges with sharp corners, breaking the monotony of the supposedly curved crater rim. This type of polygonal shape is formed by the short distance movement of crater fragments driven by strike-slip faults. In the case of strike-slip fault craters, the shearing force moves parts of the crater further apart, but these parts are still recognizable along the fault trace. The next type covers craters with parts that are allocated along a normal or reverse fault plane. The crater fragments are still recognizable on the original surface of the footwall and hanging wall block. The formation of thrust faults, a reverse fault, with a hanging wall that moves up and over the footwall, causes the hanging wall to cover certain parts of the footwall top, including craters, leaving fragmentary or incomplete craters behind. The essential difference between faults is that normal faults are formed in an extensional stress field, while thrust faults are formed in a compressional stress field. Shear forces form strike-slip faults, and the blocks move horizontally, sliding alongside each other. The crater mapping result became the foundation of further geological studies. The walls of larger craters with recognizable structural geological features were also studied. Putative faults can be observed in the walls of Sylvius and Daucus. Thrust faults, or, as an alternative, listric faults, may be recognized crossing the Amata crater, and the features observed at the Catillus crater indicate a normal fault system. Based on the crater mapping and the identified tectonic features, a subduction or subsumption-like setting can be reconstructed. We may speculate about the region's geological evolution as well. It might start with rift formation, a juvenile phase driven by extension, indicated by the tectonic features of Drepanum Chasma, which triggered the northwest movement of the Prutanis-Alcander block. The collision of microplates and the closure of the area between Palatine and Eurotas Chasmata marks the mature phase of microplate tectonism. The convergence of two tectonic plates might lead to the subsumption phase, a subduction-like process in which one of the microplates slides under the other one. Despite its sometimes speculative nature, this study provides some new information that may be considered in future investigations targeting one of the most enigmatic regions of Dione.